If you are eating less, training harder, and your belly still refuses to shrink, listen carefully to this. The problem may not be your discipline. It may be your biology. Visceral fat is not the soft layer you can pinch under your skin. It sits deep inside your abdomen, wrapped around your liver, pancreas, and intestines. And the most dangerous part is this: it is not passive. It behaves like an active endocrine organ. It releases inflammatory cytokines. It interferes with insulin signaling. It directly influences how your liver processes glucose and fat. In other words, it is not just stored energy. It is a metabolic control center that can go off track. I have worked with people who ate the same number of calories and followed the same training program. One person lost significant belly fat. The other barely changed. If everything were purely calories in and calories out, that should not happen. But in real clinical observation and in metabolic research, it happens all the time. Because your body does not simply count calories, it reads signals. When insulin stays elevated, your body receives one clear message: store energy. When low-grade chronic inflammation is present, visceral fat is protected as part of a survival response. When the liver produces excess glucose even when you do not need it, the internal environment becomes favorable for storing deep abdominal fat. The issue is not that you lack effort. The issue is that you are trying to overpower a complex biological system with willpower alone. Visceral fat is especially sensitive to inflammation and insulin resistance. Research consistently shows that higher levels of C-reactive protein, reduced insulin sensitivity, and increased liver fat are associated with higher visceral fat. And here's something most people miss. Losing overall body weight does not always mean you are optimizing visceral fat loss. You can be lighter on the scale and still metabolically inflamed on the inside. This is where most strategies fall apart. We are taught that fat loss is a mathematical equation. But in reality, it is a biological equation. Two people can both eat 2,000 calories per day and have completely different hormonal and metabolic responses, depending on food quality and metabolic health. Same number, different outcome. I am not saying calories do not matter. A calorie deficit is still foundational. But if you focus only on eating less without adjusting the deeper biological signals such as inflammation, insulin, liver output, and gut health, you are ignoring the most powerful layer of the system. Think of your body as an operating system. If the internal signaling pathways are dysregulated, you cannot just press the keyboard harder and expect the program to run smoothly. You have to correct the code. In this video, I want you to see visceral fat in a completely different way. Not as an enemy to punish, but as a biological response adapting to the environment you create every single day. And when you change that environment through precise nutritional signals, the system begins to recalibrate on its own. In the next section, we will break down the three major biological switches that determine whether visceral fat continues to survive or begins to shrink. Once you understand these switches, you will never approach fat loss the same way again. Now, let us move to the core of the issue. If visceral fat is driven by biology, then we need to identify the switches that control it. There are three major biological drivers that consistently show up in metabolic research: chronic inflammation, insulin resistance, and excessive liver glucose production. First, chronic low-grade inflammation. Visceral fat thrives in an inflamed environment. It does not just sit there. It releases inflammatory messengers such as tumor necrosis, factor alpha, and interleukin-6. These compounds interfere with insulin signaling and create a vicious cycle. The more inflammation rises, the more insulin resistance increases. The more insulin resistance increases, the easier it becomes to store fat deep in the abdomen. Large population studies consistently show that higher levels of C-reactive protein, a marker of systemic inflammation, are strongly associated with higher visceral fat mass. This is not cosmetic inflammation. This is metabolic inflammation, and it changes how your body partitions energy. Second, insulin resistance. Insulin is not the enemy. It is a storage hormone that keeps blood glucose under control. But when cells stop responding efficiently to insulin, the pancreas compensates by releasing more. Chronically elevated insulin shifts the body towards storage rather than release. Fat burning is suppressed. Fat storage is promoted. Multiple controlled trials demonstrate that improving insulin sensitivity leads to reductions in visceral fat, even when total body weight does not dramatically change. That is because visceral fat is particularly sensitive to insulin signaling. When insulin normalizes, the internal command to store begins to weaken. Third, excessive liver glucose production. Your liver constantly produces glucose through a process called gluconeogenesis. This is normal and necessary. But in insulin-resistant states, the liver often keeps producing glucose even when blood sugar is already elevated. That excess internal glucose production maintains higher insulin levels and reinforces fat storage signals. Research on metabolic syndrome shows that elevated hepatic glucose output is tightly linked to increased visceral fat and fatty liver. When liver fat improves, visceral fat frequently follows. The liver acts as a metabolic gatekeeper. If the gate is malfunctioning, fat accumulates behind it. So here's the pattern. Inflammation increases. Insulin resistance develops. The liver overproduces glucose. These three systems reinforce one another, and visceral fat becomes the structural result of that feedback loop. If you want visceral fat to shrink, you do not just attack calories. You stabilize inflammation. You restore insulin sensitivity. You regulate liver output. Those are the real switches. Now that you understand the three switches, we move to the practical layer, which foods actually influence those switches in a measurable, biological way. Let us start with inflammation. Fatty fish, such as salmon, sardines, and mackerel are rich in omega-3 fatty acids, specifically eicosapentaenoic acid and docosahexaenoic acid. These compounds reduce inflammatory signaling inside fat tissue. Clinical trials consistently show improvements in insulin sensitivity and reductions in liver fat when omega-3 intake increases. When inflammation drops, visceral fat becomes metabolically less stable. It loses its protective environment. Walnuts work in a similar direction. They are high in polyunsaturated fats and alpha-linolenic acid. Long-term dietary studies show that higher intake of these fats is associated with lower visceral fat accumulation and better insulin response. They do not burn fat directly. They improve the environment that determines whether fat stays or goes. Next, insulin signaling and oxidative stress. Dark chocolate with at least 85% cacao contains flavanols that improve endothelial function and insulin sensitivity. Control trials show modest reductions in body fat percentage and improvements in glucose handling when high flavanol cocoa is consumed consistently. The effect is not dramatic, but it is real. The key is concentration and moderation. Broccoli sprouts are even more metabolically interesting. They contain high levels of sulforaphane, a compound that activates the NRF2 pathway. NRF2 regulates antioxidant defense and reduces inflammatory gene expression. More importantly, sulforaphane has been shown in human studies to reduce excessive liver glucose production. That directly targets one of the main drivers of visceral fat accumulation. Small daily amounts can shift liver signaling over time. Now we address the gut. Chia seeds are rich in soluble fiber. When fermented by gut bacteria, this fiber produces short-chain fatty acids such as butyrate. These compounds improve insulin sensitivity and reduce inflammatory signaling. Meta-analyses show reductions in waist circumference with regular chia consumption. That is not magic. That is microbiome-mediated metabolic regulation. Greek yogurt supports this from another angle. It provides protein for satiety and muscle preservation, but it also supports beneficial gut bacteria. Observational research consistently links yogurt intake with lower abdominal obesity. While causation cannot be fully established, the mechanistic pathway through protein intake and microbiome support is biologically plausible. Blueberries add another layer. They are rich in anthocyanins, a subclass of polyphenols shown to improve insulin sensitivity and promote fat oxidation. Population-level data associate higher anthocyanin intake with lower visceral fat. These compounds influence cellular signaling, not just calorie load. Finally, extra virgin olive oil. Its polyphenols activate the AMPK pathway, the same cellular energy sensor stimulated by exercise. When AMPK is activated, the body shifts toward burning stored fat rather than storing incoming energy. It also interacts with sirtuin pathways that improve mitochondrial efficiency. This means your cells become better at using energy instead of stockpiling it. Notice the pattern. None of these foods are extreme. None require restriction. Each one targets inflammation, insulin signaling, liver output, or gut-mediated metabolic regulation. This is not about adding random superfoods. It is about deliberately sending consistent biological signals that weaken the survival advantage of visceral fat. In the next section, we will bring this together into a practical metabolic strategy you can actually implement without turning your life upside down. Now, we bring this together into something practical, because understanding biology is powerful, but implementation is what changes your body. First, accept this clearly, you still need a calorie deficit. There is no bypassing energy balance, but the size of that deficit does not need to be extreme. In fact, aggressive restriction often increases stress hormones and makes the system more unstable. A moderate, sustainable deficit combined with high-quality metabolic signaling is far more effective long-term. Second, build meals around signal density, not just calorie density. Include fatty fish 2 to 3 times per week. Add extra virgin olive oil instead of highly refined vegetable oils. Use a small handful of walnuts as part of a meal, not as a snack you mindlessly overeat. Add half a cup of fresh broccoli sprouts daily if possible. Rotate in blueberries. Use chia seeds strategically in yogurt or oatmeal. Choose high cacao dark chocolate in small portions. You are not chasing superfoods. You are layering signals. Third, combine this with muscle stimulus. Resistance training improves insulin sensitivity independently of weight loss. Zone 2 cardiovascular training enhances mitochondrial efficiency and activates the same AMPK pathways we discussed earlier. When nutrition and movement align, the biological message becomes consistent burn. Do not store. Fourth, protect your metabolic rhythm. Chronic sleep deprivation increases insulin resistance and inflammatory markers. Late-night eating keeps insulin elevated when your system is designed to downshift. Consistency matters more than perfection. Visceral fat responds to repeated patterns, not one perfect day. And here's the part that requires maturity. None of these foods are magic. The studies we discussed show modest but meaningful effects. Some are randomized controlled trials. Some are observational. Effect sizes vary. Context matters. Genetics matter. Baseline metabolic health matters, but the direction is consistent. When inflammation decreases, insulin sensitivity improves, liver glucose output stabilizes, and gut health strengthens. Visceral fat loses its survival advantage. That is the strategy. You are not fighting your body. You are correcting its environment. Let me leave you with this. Visceral fat is not stubborn because you are weak. It is persistent because the biological signals around it support its existence. Change the signals. And over time, the structure changes. If this perspective shifts how you think about fat loss, then this video has done its job. In the next episode, we will go deeper into the specific training protocols that amplify these metabolic pathways even further. Because once you understand the system, you stop guessing. And when you stop guessing, results stop feeling random.